morning. My name is Konstantin Eremin. I work for the Internal Audit Department at Sberbank. I'll tell you about a practical case of using computer vision to solve one of our problems. As many of you know, since the start of this year, we're running a mask regime throughout Russia, and that includes Sberbank employees. But then we've got a question, how you could verify that? So the task is to identify who the employers is not complying with the regime. So actually we decompose it into several subtasks. First, we need to find the employee in a frame, in a picture frame, and then to identify how they're turned versus the camera. It would be very strange to look for a mask on the back of their head or at the side when we couldn't see the mask. And it would be wrong to say that the employee is not wearing a mask because we can't confirm the fact. And the next step would be to understand if they are indeed wearing a mask or not. So computer vision is there to help us. Actually, the types of computer vision tasks are usually classified in 4 types. A classification, identifying the image, segmentation, object detection, identifying all objects of the predefined classes and determining the frame for each of them, and object segmentation, determining the pixels that belong to each object. And for our task in hand, we could use either object detection or segmentation, but also because we have ideas how to use the information to identify the distance between people, we can mathematically calculate that. So perhaps we would use instance segmentation for this task. So as a result, we are getting the following approach. So we have a camera from which, in order not to analyze the entire video stream, because that would be too resource intensive, we could analyze specific images taken with a certain frequency, once every second, for instance. Then the image from the camera is passed to the neural network. In this particular case, it's mask RCNN, after which we identify the location of the person using a PyTorch open pose. And then we use a classifier, for instance, ResNet 50, to identify if the employee is wearing a mask. Let's consider the approach step by step. Step 1, right after we received the image, is mask RCNN. Mask RCNN works like this. So the picture goes through a series of convolutional neural networks, and at the output you get the feature marks. Based on these features, we identify the regions of interest, and in each slide they're highlighted with red. The brighter the color, the more interest we have to this area, the more feature marks there are there. And so we identify a class for each region, the class of the object that we need. In this particular case, our task is to identify, we have 2 classes, employee and client, because there are only 2 types of people normally in such images. After we've identified the employees, we need to understand the position of the employee. Here, PyTorch Open Pose comes to our help. Using this software, which works very well, we can identify 17 key points in the body of each person. So the facial key points, there are 5 of them, can be used to understand the position of the attitude and position of the person versus the camera. So if they're turned with their face to us, then using a simple classifier, we can identify if they're wearing a mask. If they're wearing a mask or not. Then we get into the most exciting part, to understand why the neural network has made this or that decision. So we have trained the neural network, and then we need to understand how well we have trained it. And we can do it by viewing the metrics, and we can visualize how the neural network is thinking based on what it has taken this decision, what it's looking at. This approach is called GradCam. Well, perhaps it's the easiest and the most reliable way to visualize these things. The essence of this is that we identify those features based on which that the convolutional networks have used. So based on that, we can either offer additional training to the network or to improve its quality by filtering out inefficient features. So we select a class, run the image, calculate the gradient, and then average the output, and we get this heat map. That's the top. That's the far right corner. The more there is red, the more important this feature is. So let's apply it to the neural network that we've got. And here, the class is Sberbank employees. So we applied it, and we see that the employees, as a rule, well, the most important feature is a green tie and sometimes a tablet. And that is indeed true, because all Sberbank employees in offices wear a uniform that has these attributes. Thank you for your attention.